I mentioned earlier that the key to L'Hopital's rule is that we're taking a limit of 0 divided by 0, right? That's an indeterminate form, and it's called an indeterminate form because 0 divided by 0 kind of gives us a contradiction. 0 divided by anything is 0, anything divided by 0 is infinite, so we have one rule saying it's 0, one rule saying it's infinite. That's not the only indeterminate form that we can use L'Hopital's rule with. So an indeterminate form is just an expression without meaning because the operation can't be directly evaluated. You don't need to write that definition down. You don't have to memorize it. But just understand that 0 over 0 doesn't mean anything. We can't evaluate that. We could actually make 0 divided by 0 be any number we want. We can make it equal pi if we want. We can make it equal 7 if you want. You can make that equal anything you want depending on how you get the 0 over 0. There are a bunch of other indeterminate forms. For example, and I already showed this to you, if we say that the limit as x approaches a of f of x over g of x equals infinity over infinity, we can change that to this, and this is going to be 0 over 0. So it allows us to use L'Hopital's rule when we get this indeterminate form, infinity over infinity. Okay, again, this is a contradiction because infinity itself is infinite, but if we divide by an infinite number, we get 0. So we have one rule saying it's infinite, another rule saying it's 0. So we get something in between, maybe. All right. There are actually 7 indeterminate forms that L'Hopital's rule works with. 0 over 0 is 1. Infinity over infinity is 1. Infinity times 0, again, 2 contradicting rules. Infinity times anything is infinity, but 0 times anything is 0. Infinity minus infinity, we can use L'Hopital's rule for that. And then we've got some exponential ones here that are kind of fun. 1 to any power is 1. Anything to the infinite power is infinite. So we've got contradictions there. Anything to the 0 power is 1. 0 to any power is 0. So another contradiction here. Also an indeterminate form. And then infinity to the 0. All of these things we're going to be able to apply L'Hopital's rule in some way to evaluate them. One thing I want to look at here is how we can use substitution to change a problem into an easier problem to work with. This limit here is a limit that we know, but in the form that it is, it's not that easy to work with. So sometimes we're going to be required to change an infinity into a 0, or a 0 into an infinity, which is a little bit trickier, but not that bad. So what I'm going to do here is I'm going to use substitution. Anybody want to guess what substitution I might use here? I'm going to let u equal something. 1 over x. So if we say u equals 1 over x, then we can make a fairly straightforward substitution. That also means that x is going to equal 1 over u if we solve this equation for x. So the expression here is easy to change. We'll get to this part in a second. So x here becomes 1 over u. 1 over x here becomes u. And then what we need to deal with is this part. X is approaching infinity. So if we look at this right here, if x approaches infinity in this expression, what does u approach? Yeah. So if x approaches infinity here, then u is going to be 1 over a really big number. So u is approaching 0. Now we need to be more specific than that. U is approaching 0, but since x is approaching positive infinity, then u is approaching 0 from which side? From the right. In this particular problem, that doesn't matter. In a lot of the problems we'll do, it will matter. We'll need to know that we're either coming from the right or coming from the left. So this limit right here turns into this limit here. So we've changed the infinity into a 0. We're taking the limit as u approaches 0. And what is this limit? Would it help if I rewrite it? Lauren?
What?
Did you say that?
I said 1.
Yeah. That's sine of u over u, right? So the limit of sine of u over u as u approaches 0 is 1. I probably should have said this at the beginning, but this problem here is an example of, well, x is approaching infinity, so this is infinity times the sine of 0, which is 0. So this problem here is an example of infinity times 0, and what we do is we change it into a form that we can use L'Hopital's rule, which we've already done that, so we're not going to, but we do that by using substitution. Okay, we could have also done it by just writing this as sine of 1 over x over 1 over x, and what we end up with then is the same thing we got there.